Hello, today we're going to be talking about some postulates that have things to do with points, lines, and planes. So I'm just going to read through these postulates here. We're going to keep referring back to them as we go throughout these examples today. So 2.1, the two-point postulate says that through any 2 points, so we have points A and B here, there exists one line that goes through them, and that would be line L in this picture. The line-point postulate is basically the opposite of that. If we have a line, so like line L, that line contains at least 2 points, like A and B. The line intersection postulate deals with when lines cross. If 2 lines intersect or cross, then their intersection is exactly 1 point. So if you look at the picture here, I have line N and I have line M. They intersect or cross at point C. The 3-point postulate and the plane point postulate kind of go together, sort of like the 2-point and the line point did. 3-point postulate says that through any non-collinear points, 3 non-collinear points, there exists exactly one plane. So if you look at the picture here, I have points E, D, and F. They are not collinear, and so we have a plane that goes through all of those, and that would be plane R. Plane point postulate basically saying the opposite. If I have a plane, so for instance plane R, it contains at least 3 non-collinear points. So for example, E, D, and F. The plane line postulate talks about lines and planes. If 2 points lie in a plane, then the line containing them lies in the plane. So I have points E and D that are on a plane. The line that goes through them, which would be DE, is also on that plane R. And last but not least, plane intersection postulate. Now we're talking about when planes intersect instead of lines intersecting. If 2 planes intersect, then their intersection is a line. So here we have plane S, which is kind of vertical, plane T, which is almost horizontal. The way that they intersect is they intersect at line L, which is that line that's drawn in. For what we're going to do today, we are going to be identifying situations where each postulate is being used, and we will also later on use these to help us with proofs. That's coming up in the future. So let's look at some example problems there. They've basically taken a postulate but written it in kind of half word, half picture form. It says if, and then what do we have there? We might as well talk about that. Write that in, it'll help us figure out the postulate we're talking about. So we have here, we have a line. Then what do we have there? We now have 2 points drawn in on the line. So again, backtracking my steps here. First picture just showed me a line. Second picture showed me 2 points drawn on that line. So go back to our postulates. Which postulate talks about having a line and having 2 points on it? That would be this postulate right here, the line point postulate. So our answer here would be the line point postulate. Okay, let's try another one. What do I have going on in the pictures here in example B? I have here 3 points. You might notice that they are not all collinear, so we would say non-collinear. And then what do we notice about what happens in the next picture? Now we have plane with those 3 points. That plane, the green plane, is containing all 3 of those points. So let's go back to our postulates. We need something that starts with having 3 points, and then we have a plane. What we've got going on here is the 3-point postulate. It says through any 3 non-collinear points, so we started with 3 non-collinear points, then there exists exactly one plane, and that's what we see exactly going on. So that was the 3-point postulate. Wow, that doesn't look like an H. Let me fix that. So 3-point postulate. Okay, so that's just kind of looking at pictures and seeing what postulates we see happening. Sometimes also we will be given a picture and we're going to make our own examples of postulates from there. So they want us to do a few things here. 3-point postulate, 2-point postulate, line point postulate, and line intersection postulate. So 3-point postulate, that's the one we were just talking about. So the 3-point postulate says that if we have 3 points, then we have a line that goes through them, or sorry, a plane that goes through them. What we were just talking about here. Through any non-3 collinear points, there exists exactly one plane. So let's find 3 non-collinear points. I have A, B, and C. So through A, B, and C, there is plane. What plane involves all 3 of those points, A and B and C? That would be plane P. So, or you could say plane P contains all 3 of those points. Let's try another one. Let's talk about our 2-point postulate. So refreshing our memory, 2-point postulate said through any 2 points, there exists exactly one line. So let's find 2 points that have a line going through them. I have points B and A that have a line going through them. And then we can either call that line AB or we can call that line N. So what we can say here is that line N goes through A and B. Points A and B if you want to be a little more precise. That's our 2-point postulate. Next up, let's look at the line point postulate. So let's refresh our memory on the line point postulate. A line contains at least 2 points. So we can say, we can use that same thing we just looked at, line N contains points A and B. And then last but not least, we are going to look at the line intersection postulate. So let's go back to that one. Line intersection postulate said if 2 lines intersect, then their intersection is exactly 1 point. So let's find 2 lines that intersect. We know we have line N. We also have line M right here. So we can say line M and line N intersect at what point? The point where they intersect is point A. So basically what you're doing here is you are going back to these postulates and just filling in, like when it says 2 lines, name the 2 lines. When it says exactly 1 point, name that point. Things like that. All right, now the last thing we're going to do today, and I know this picture looks a little crazy, we haven't looked at a picture quite this complicated yet, is they're going to give us a picture or diagram, and they want to say if we can assume certain things from that picture or diagram. So sometimes the answer to these will be like, yes, we can say that. We know that for sure because of what's in the picture. Sometimes the answer will be no, we can't say that because we don't have enough exact information. It might look like that situation, but if things aren't specifically drawn in or written in, you can't make those assumptions. So, first thing they want to know, are points A, B, and F collinear based on the picture? So I have A, B, F. Notice that we have a line going through all of them. So we can say yes to that. There's a line drawn that shows that. Can we say that points E, B, and D are collinear? So I have E, I have B, I have D. It might look like they're collinear, but there is no line drawn in that says, okay, line L goes through them. So there's no line drawn in. So that one will be a no. No line drawn in that says that. All right. The next one, remember that this sign means perpendicular. And so they are saying line AB is perpendicular to plane S. Perpendicular means they meet at a right angle. So can we say that? Here's line AB and then plane S, and I do have that right angle little box drawn in. So since I have that right angle box drawn in, I can say yes, because that right angle is drawn in. Can I say something similar about CD, line CD being perpendicular to plane T? I don't have another right angle box there, so no, we don't see a right angle. So we can't, it might look that way, but we cannot assume it because we can only assume what is there for sure. All right, AF intersects BC at point P. So here's line AF, Here's line BC. Do they intersect at point B? Yes, they do. And it's because we can see that in the drawing. We can say yes to that. All right. Now, I'm going to get rid of some of this ink here because we've got things really cluttered up. Let's get a fresh start. Okay, next one. There exists a plane that contains points A, D, and E. So, in general, we have a plane that goes through any three non-collinear points. So here I have A, here I have D, here I have E. Even though I don't have a plane drawn in that has all three of them, we just say there exists a plane. So there's some plane out there that contains all three of those points. So this one is yes. You can say that because they are three non-collinear points. Last one is saying that line segment AB equals line segment BF, their measurements. I don't have any number measurements written in. I also don't have those congruent symbols written in. So since I don't, I'm going to get rid of those because they're not actually part of the diagram. Since I don't have anything drawn in that says that, no, I cannot assume that. There's no congruent symbols, there's no measurements, so even though they might look the same, we cannot assume that they are the same length. That is it for today for postulates. Have a fantastic day.